guys, I don't know if on the back of your assignment sheet or if anywhere else you have blank space. I don't know if you can squeeze it in there. I'm going to go to a new slide here. I'm going to draw part of the unit circle, okay? Not all of it, but part of it. All right, guys, over here at 0, like 0 pi or 0 degrees, what's my ordered pair? 1, 0, okay. Up at the top, what's the radian measure up there? Pi over 2, good. And what's the ordered pair up there? 0, 1, good. You guys remember things after Thanksgiving, good job. What about over here on the left? Pi, and in the other part? Mackenzie, what'd you say? Yeah, -1, 0. I need both parts, that's good. And then down at the bottom, good. 3 pi over 2, and the ordered pairs, 0, -1. And if I made it all the way around again, this would be 2 pi, right? Okay, we know all of that, right? We're going to use this to make the graph of our sine function. It doesn't look like much, but I promise we can do it. All right, so on this little graph you have here, for y equals sine of x, the x-axis is going to be labeled with the radians we just did around our circle. So we started at 0, and then at the top was pi over 2. Then came pi. Then 3 pi over 2. And then 2 pi. Okay, so those are just ones on the axes from your unit circle. Okay. If I wanted to label the left side of my graph, what do you think I'd do? Yeah, just negatives. This is negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Then on the y-axis, if you look at your ordered pairs, they're either 0, 1, or -1, right? Those are the only numbers we used. Okay, so that's what I need on my y-axis. 0, we know where 0 is. I'm going to use 2 tick marks to get to 1, just because it's really small, and then 2 tick marks down there is -1. Okay, so now we're actually going to figure out where the dots for our graph go. So if I'm talking about sine of theta, from the unit circle, that was just y, right? Okay, so when I start over there at 0, what is the y value? Like when I'm at 0 radians, over there on the right, what's the y value of the ordered pair? 0. So on your graph, you start at 0, 0. Okay, when I go to pi over 2, so the input is your radians. When I'm doing pi over 2 radians, what is the y value there? In other words, what's the sine of pi over 2? Yeah, 1. So at pi over 2, I'm at 1. What's the sine going to be when I'm at pi? 0 again, good. What about 3 pi over 2? -1, good. And then 2 pi. All the way around, we're back to 0, right? Yes, there's lots of zeros, that's okay. All right, let's look at these dots. So if I start from the end over here to look at my pattern, It's 0, -1, 0, +1. 0, what do you think is going to come next? So we're going to follow the same pattern. So 0, -1, 0, +1. 0, 0, 0. Okay? You guys see it? Same pattern the whole way through. So this one's -1. 0, +1, 0. Question? All right, is everybody okay with the dots? Okay, we have to actually make a shape out of this. So when you look at your circle here, that's not a straight line, right? We have a curve like between each of these values. So on your graph, it's the same idea. It's not straight lines. This is not like a pointy graph. It's a sinusoidal curve. So the way you draw it, like that. And it will keep repeating forever, but we don't really put arrows on the end of it. That is the parent graph for your sine function. The way we're going to graph all of the other graphs from here, you're going to start with this parent function graph. Like, you know those dots, you know the placement of them. And then we're going to do shifting, stretching, reflecting, everything like that. But you start with that original graph every time. There's no like plugging values in while we graph this unit. Okay? It's all understanding how the graph itself moves. Okay. All right. We're going to try to do cosine now. So in the exact same process, see if you guys can graph cosine for me. Talk to each other. I'll give you some time. Don't be scared. It's going to follow that pattern every time. So it's going to happen, like that pattern of like low, middle, high, middle, low, middle, high, like that's going to happen every time you graph one of these. Okay. How we doing, guys? Are you scared to draw it, or are we okay? You drew it? You went for it? Good. Okay, yeah, let's see. So guys, did you start with the same labels? Yeah, okay. And I know it's tedious, but the way we graph, labeling the x-axis becomes a very important piece of this, so we have to do it, okay? All right, cosine does not start at 0, 0. It starts up here at 1. Kind of looks like a W. Okay, how do we do? Give you a minute. Any changes that need to be made, go for it. All right, guys, any questions on the two parent graphs? We feel okay with those? Okay, let's look at how we can change them. All the different things we can do. So see down here where we've got this shifting and then the A's and B's and C's and D's. Those are all the different things we might do to our graph, okay? We're not going to do all of them today, but we're going to start looking at them. All right, so amplitude, that is what you're stretching it by. So if we want to make our graph taller, if it gets shorter, anything like that. Where we find that in the equation, that is the absolute value of A. So if you've got a coefficient out in front of the sine or cosine, that is where you find your amplitude. So you can think of this as the vertical stretch with the other types of graphing we've done. Okay. All right, the period of the graph. What that is talking about is how long does it take for the graph to start repeating. Do you guys see how this graph just, it's a wave and it keeps happening over and over? Okay, we need to know how long it takes for it to start repeating. Do you guys see it, this one? Okay, there, and then it would begin again. So how long is that? What do you think? 2 pi, right? Does it take one time around the circle before we start repeating? Okay. So the period, the way you figure it out, it always starts as 2 pi, and then we're going to divide it by b. B, you can see in here, it's the coefficient on the x. So for the 2 parent graphs, that coefficient was just 1. Now, C and D, this is something that should be familiar to you with your other graphing. The plus C or minus C in the middle there, if it says plus C, which way do you think we go? Left. Good. And what if it says minus C? To the right. Yes, good. All right, so that's your horizontal shift. Sometimes it's called a phase shift. And then what about the D value? What do you think that's going to tell you? Yeah, up and down. If it's positive, it goes up. If it's negative, it goes down. All right, then if A is negative, so we've said the absolute value of A was the amplitude. What do you think a negative in front of your equation is going to do? Flip it, yes. Yes, so and when A is negative, the graph will flip over x-axis. So let's look back at our parent functions again here and see if we can see some of this stuff. So I asked you on the first one the period and the amplitude. What do you think those are for this parent graph? You already told me what the period was, right? It's just 2 pi. And what's the amplitude? 1. So on your graph, we have something called the midline. So it's not an asymptote, but I'm going to just show it with a dashed line in the middle here. That is your midline. For the parent graphs, it always ends up being the x-axis. And then do you guys see from, I'll label you first. Do you guys see how from the top of the graph to the midline, how far is that from the top to the midline? 1, okay, that's the amplitude. So amplitude is always talking about from the midline to the top or from the midline to the bottom, okay? If I look at cosine, what do you think the period and the amplitude are for the parent graph of cosine? Same, yeah, 1 and 2. Okay. All right, so let's try to graph one where something changes. So let's look at number 3 here. We have the equation y equals 3 sine of x. So what do you think changed, the amplitude or the period? Amplitude, okay? Amplitude became 3. The period is still 2 pi. Since the period is the same, my x-axis is going to be labeled in the exact same way. When we get to graphs where the period changes, we're actually going to change how we label the x-axis, but so far we don't need to do that. So this is just going to be the regular pi over 2, pi, 3 pi over 2, and 2 pi. On the y-axis, I'm still going to go by 2s, so 1, 2, or like every 2 tick marks. What do you think is going to look different from the parent graph? It's going to get like taller, right? Okay. So those dots, what you're really doing is you're going to take the y value times 3. So if you look at your parent graph for sine, I always like to start on the y-axis. That starts at 0, 0, right? Well, what's 3 times 0? Okay, so that one's not going to go anywhere. Pi over 2, normally it's up at 1. So where do you think it's going to be this time? 3, yep. What about pi? Back to 0, good. 3 pi over 2. Instead of -1, where is it going to go? -3. Good. And then 2 pi is back to 0. All right, and then you can follow the pattern on the left. It's going to repeat. You can look at your parent graph and think about multiplying however you want to get those dots on the left. I know this one's going to be down, middle, top, middle. Bless you. So I graph it. How do we feel about this so far? Is it going to be another good unit, guys? Fingers crossed, yes? Okay. All right, guys, questions before we turn the page? Okay, then. All right, we're not going to do all of these today, don't worry. Let's get through a couple more. All right, number 4 here. What's different in this one? Is it the amplitude that changed this time? No, it's the period, right? You guys see that b value? When the coefficient is on the x, that means that's the b value, okay? This is b. So the amplitude's still 1, but the period is now 2 pi over 4. Well, what is 2 over 4 reduced to? Good. Yeah, we know that, right? 1/2. A little worried today. So the period is pi over 2, okay? So what that means is we have to completely relabel our x-axis. So instead of it taking to 2 pi for the whole graph to happen, it all happens by the time we get to pi over 2. I don't want to show this teeny tiny little graph, so what I'm going to do is relabel the x-axis out to pi over 2. Like this ends up being my last one. Okay? That was 2 pi before. How did I turn it into pi over 2? What did I divide by? Yeah, divided by the b value of 4. So think about, there's 2 ways you can think about it. Your original labels and divide each of them by 4. Or you can think about fractions and what's halfway to pi over 2 and halfway to that. I don't think you guys like to think fractions all that much. So we'll just do some dividing here. So 3 pi over 2 divided by 4, I want to make sure you understand what that means. I'm going to divide that by 4. That is the same as 3 pi over 4, I'm sorry, over 2 times 1 over 4. You guys realize that? Like the 4 is just 4 over 1. I can flip when I'm dividing by a fraction. So what is that going to become? 3 pi over 8, okay? So that's this label. So I can get rid of these two. What do you think the old label of pi is going to become? Pi over 4, sorry, said, yeah, pi over 4, good. And what about pi over 2? Pi over 8. And then my negatives. All right. Okay so far? Okay. Once you have relabeled, all you have to do is put the parent graph dots in the same position as they were originally. So this is a cosine graph. So I know it's going to start up at 1. The next tick mark is going to be 0. The next tick mark over is -1. Then it's 0. Then it's +1. You're just following that exact same pattern. It looks exactly like the original, right? You guys see why labeling the x-axis is going to be really important? Because that's the only way we know we've done something different. Okay? You don't have to write this down. I just want to show you what's actually happening when we change the period like that. That's not very straight. All right, so I'm going to graph the regular graph here in this color, and then I'll graph the one we just did. Again, you don't have to write this down. I just want to make sure you see what is happening. Okay, so the parent graph looks the same. The changing the period, making it 4, that means the entire graph happens by the time I get to pi over 2. Okay. What we graphed on ours was just this little window right in here to pi over 2. We kind of just zoomed in on that part. Does that make sense? Okay, so it's like it's speeding up how quickly it happens. If you look at it, count for me how many times the red graph repeats by the time I get to 2 pi. 1. Oh, there were 4 of them, and that's a 4. Okay, so what that b value is telling you is how many times the graph will happen by the time you get to 2 pi. Okay? For graphing it, though, we don't have to do all of these. You don't have to show me 4 of them. You don't have to get all these crazy squiggles going on. Just understand that we're like zooming into a different viewing window. Okay? Questions so far? We will do a lot of practice with this. All right, let's go back here. Okay, let's try number 5. I want you guys to try to just get your x-axis labeled first. Don't worry about actually graphing it yet. I want to give you a minute to try to label this. Talk to each other, guys. I see some non-labeled x-axis. 2 questions. Why did the calculator up? All right, so we're doing a good job with the axis, which is a big piece of it. All right, so on this one, the period, do you guys get, ends up being 4 pi, okay? Yes, so your labels end up just being pi, 2 pi, 3 pi, 4 pi. Are we okay with that? Everybody gets that, okay? And always look at your axis after you've labeled it. Like, are the numbers in order? Does it make sense what you wrote down? Just to make sure you catch any little mistakes. All right, now the amplitude. What'd you tell me for amplitude? Okay, see? That's why you gotta catch it. Just read through them. What's the amplitude this time, guys? 2, not -2, right? +2. But does the negative matter? Yes, it does, okay? All right, it is sine. Sine normally starts at 0. And again, we're just taking all the y values times that leading coefficient. So 0 times 0 is still 0. Normally, then it would go up to 1. Where is your graph going to go? Down to -2, right? Okay, we're going to go ahead and flip it and stretch it all at the same time. So we're going to be down here. Next would be 0. 0 is still 0, okay? All right, after that is normally +1. Where are we going today? 2, yeah, it gets, I'm sorry, it's normally -1, so it's +2. And then 0 again, right? Are we doing okay with the pattern then over to the left side? So it's middle, high, middle, low, middle, high, middle, low, middle. Okay. Okay, I'll draw this in there. All right, how'd we do on that? We okay? Okay, guys. So for notes today, all we were doing is an amplitude change and a period change. We're not going to do the shifting ones yet. We will do those next. So that's going to be 6, 7, 8, and 9. So what I want you to do right now is look in your packet for classwork 4.1. Should be like the next page, okay? All right, there are 8 graphs on here. Let's do 1 through 4 right now. So, in your group here, at the top of each one it says amplitude, period, and shift. We have not done any shifts yet, so there will be no shifts. You don't have to put anything there. Fill in the amplitude period and then graph it just like we've been doing, okay? And I will walk around and check and see how you're doing. to drawing this.